Hi there. Today we're looking at calculating moles. Now we've looked at moles before and realised that moles have 6.022 times 10 to the 23 atoms in every 1 mole. We've looked at what molar mass is, and that is the mass of 1 mole of that element or compound. We've done some conversions, looking at converting the number of moles to mass, the number of moles to atoms, and all those variations in between. And today we're going to start looking at some of these practical applications of the mole. So this formula here that we have on our screen, moles is equal to the mass of a substance divided by its molar mass, is a formula you're going to use a lot, and it's important that we need to know how to use it, and that we become quite competent and confident in using that. So if at any stage you experience difficulty in the concept with the mole, it's really important you touch base and get some help from me. Because this is something that we're going to be using pretty much in every module from now on, and it's the underpinning of everything really that we're doing in our chemistry. So as I've mentioned before, there's ways that we can put this into a into a triangle like we have done. Personally, I think it is much better that you know how to alter your equations and the subject of your equations in an algebraic form, which you do in maths, always changing the subject of the equation. But this is always here as an option. Again, if you're wanting to find the moles, cover up the number of moles and we're left with mass over formula mass. If we're wanting to know the formula mass, it'll be mass over the number of moles and so on. So let's have a look at a couple of examples. And this one is in your booklet, and I want you to work along with me, filling things in as we go, and then we'll move on and have a go at a few of them on our own. So the first question is, how many moles would you have in 7.09 grams of chlorine gas? So it's always really good if you can be really clear about what it is you're wanting to find and what information you currently have. So in this case, the mass we have is 7.09 grams. The molar mass, you might not know off the top of your head, but certainly can work out. And we have chlorine gas is Cl2, so its formula weight is actually 2 lots of the mass of 1 chlorine atom, so it'll be 70.90. So the number of moles that we have is 7.09 divided by 70.90, and we have got 0.1 moles. Now, it's really important when we're doing these calculations again that we write our units. I do actually usually find that it is better if you write the units even in here, like grams and grams per mole, and that enables you then to cancel out the grams and you're left with mole, which is what the units will be, and that way then you're less likely to make some silly errors there. Let's have a look at the next one. How many moles are there in 8.8 grams of carbon dioxide gas? So again, let's write down the information we know. Some of you are a little bit lazy with doing your working, and it's really important that you take this time, set your working out properly. So the mass is 8.8 grams. Our molar mass is 44 grams per mole. So now in putting that into the question, and again, like I said, we should actually put that in there right now and go grams per mole. So we have got 88 grams divided, or 8.8 grams, sorry, divided by 44 grams per mole. Again, the grams cancel each other out and we're left with 0.2 moles of carbon dioxide in 8.8 grams. So what I want you to do is to work through questions on page 57, 58, 59 and 60. There's a load of them. It may be that it will take us more than one lesson, particularly with us helping, but we'll evaluate that as we go. So we'll work on this in class and then see where we're up to and how long it needs to go for. If we're finding this is taking us a little while to get our head around, it may be that we need some more problems. And if that's the case, then we will take some more time to work on that. So we'll talk later today. Bye.